In this video, we will see about Raspberry Pi Pico and how to get a digital to analog converter signal from a Raspberry Pi Pico. So we know that Raspberry Pi Pico is a quite a powerful microcontroller. It has a Cortex M0 plus microprocessor, and it has many features like it has got I2C, it has got SPI and other such features. And one thing that is missing is DAC. We have ADC where we convert our analog signal to digital signal, but then we don't have DAC. There are many applications which actually demands analog signal coming out of a microcontroller with appropriate circuitry. Unfortunately, it's not in a Raspberry Pi Pico, but that's not going to stop us from limiting it. We are going to create a DAC in this video. So we know that there are so many microcontrollers and that's available right now, and it is always necessary that we have to control the electronics using microcontrollers which are analog, right? So and for that purpose we obviously need a DAC, digital to analog converter. And then, as I told, not all microcontrollers have a DAC, so that is what we are going to do. But here we are going to do with a very simple component. We are not going to get into the, like, you know what, hi-fi systems. We are not going to use any ICs. Rather, we are going to use something which we have already studied in our basic classes. Like in LIC, we have studied DAC. In DAC, in DAC there are different types of that. We are going to employ simple R2R strategy or to our configuration of converting the digital signal to analog signal, right? So yes, we are going to use a 2R, and here you can have actually different ways of doing it. You can create like different ways, and you can have a different bit DAC, but here I'm going to restrict it to 4-bit DAC because of like the complications. There would be complication if you have an 8-bit, because you'll have to use 8 individual uh, pins connected to GPIO, and the wires, the resistors, everything will get a little complex. And not just that, the noises induced with the exposed resistors can also create unwanted waveforms, unwanted noises. And even in our experiment, in the video, at the end of this video, we'll be seeing about seeing the output video, where you can see that this output also has so much noise. The reason is because it's exposed resistors, and there are environmental factors that cause noises. So yeah, let's for the demonstration purpose, let's proceed with just a 4-bit DAC. And I'm going to use this particular configuration that you see on the screen, 4-bit DAC. This actually designed with Falster, which you have already have enough, you are acquainted with. And then in addition to that, um, we'll be putting that in the Raspberry Pi Pico, and this is the expected waveform. We will not be getting an exact sine wave. The sine wave will be like this, the small steps, as you see, the steps. And this is how I'm going to connect. So the connection is going to be with the Raspberry Pi Pico through the resistors. So here the voltage, the power voltage will be from the digital pins itself, and then one particular part is grounded, which is something which we saw in the previous video, previous slide itself, the configuration. And this is how uh, we actually implemented. But then before connecting, if you see here, I have not connected my Raspberry Pi Pico to the computer, but still my DSO is picking up some noise. So this is a problem with exposed resistors, and we have bulky wires and things, so they may not get the expected output. But then for the demonstration purpose, we are going to go ahead. We are not going to worry about the noise here. We are going to see if we can really create a wave, right? And this is the connection, open connection. Please ignore the color combination here. For the sake of demonstration, I've connected. Please ignore the colors of wire. So I'm playing this video. You see
the configuration of the DAC that I have connected using R2R connections, and you can see the inputs where I have connected the digital pins. You can see a small this marks the marks over here and here, and then there will be another one here and the other one other side. So you have 4 bits connected to the GPIO, right? And then this is where I'm taking the output at this part, and here the ground. So it should be the black wire and red wire on the opposite side, but for the demonstration purpose I have mixed it up. And this is the output for a sine wave, right? And this is the Python program. The program is quite simple. I'm initializing few libraries, the machine library, utime, math. The reason why I've initialized maths library is because we need to create a sine wave, and this is the formula for creating a sine waveform. And then I have defined a function exclusively to create or to give the values for the R2R ladder. Then I have set a frequency of 1000 Hz and a delay, and then I have started my program inside a while true loop. Now after compiling this, when I run the program, you can see the output in the DSO, the sine waveform. Right? So this is not the exact sine waveform. As I told earlier, we have a lot of noises, and because of that we are not getting a perfect sine wave, but still the sine components would be here. And another reason is that it's also a 4-bit DAC. Now we will try to this is the output you get for a triangular waveform. I have changed the program. I am running the triangular waveform program now. If you see, after making small adjustments, you can see that the waveform is actually a triangular waveform, but then there are a lot of noises. If I increase the time period, I can see the noises, but then when I reduce it, you can see an acceptable triangular waveform, right?
So this other waveform that we get as an output. So this is a triangular waveform, this which we got in our DSO. You can see the triangles are actually formed, but you can see the noises along the signal. Similarly, the noise gets worsened in sine wave. This is a sine wave actually, but still we're getting a lot of noise. And another another issue is that we are using a 4-bit DAC. So it's just a 4-bit resolution. So the possibility of getting some noises.
Right, now that we saw the output waveform, I think it would be important for us to understand the program as well. Right, so this is the program that I've used to generate the sine waveform, and here I've used 3 libraries. I've initialized 3 libraries: machine, utime, and math. Machine is for the Raspberry Pi PICO, that is the controller that we are using. And then this is the library which makes the lines like the pins, outputs, and other things to run, right? And then I've initialized another library, utime. This is to create the delay necessary for our program, for our waveform to be generated. And then I've also used another library which is math to generate a sine waveform, right? So all this library has their own documentation. You can refer in their official website to understand more. And then I have set this pins 16, 17, 19 and 20, which are the digital pins of RP2040. I have connected it to the R2R network, and then the output, right? And then we have a resolution of 16 because it's a 4-bit DAC. And then the sine wave, this is the formula which is already available with this library. All you have to do is just put in the formula. And then I've written customized function write to R2R. This is to take in this value and continuously provide it to the system so that you get a sine waveform, right? And then for frequency, I've set 10,000. You can change the frequency. You can keep it as a different frequency, and you can see how the results are varying for different frequencies, right? If you use a DSO and if you put it in automatic mode, you will not be able to see much of a changes, but still you can see some differences, right? And then the delay for creating a waveform again. Then inside the while loop, I've put the program line to continuously run with a small delay. So the delay is in such a way that you get a perfect a sine wave. But then in paper, it's actually a perfect sine wave. But if you see in the DSO or other display devices, you can see it's not a proper sine wave because of the 4-bit DAC, right? And added to that, we are using exposed resistor and not a proper so like the wires again, all those things contribute to the noise, right? So thank you.